As the next thing, I will talk a little bit about pressure drop and static pressure measurements. Basically, when we talk about static pressure, it could be a negative value or it could be a positive value. In this particular system, at the suction side of the fan, we will talk about vacuum, which is negative static pressure. And on this side here, after the fan, since we are going to atmosphere, this part of the duct system is under positive pressure. So let me zoom in into just this part of the system. Here at point A, I am measuring the vacuum level, and it is about -2 inches. And here, just a few centimeters downstream here, I have a very similar static pressure of about 2 inches, because there is not much pressure loss from here to there. But now what I will do is I will create some resistance and pressure drop in the system by taking this slide gate and push it in. And what I want you to see is that the moment I do this, these instruments, they will not show the same thing anymore. What you will see is that the vacuum level here, it will decrease, and on that side it will increase. So you're looking at these two instruments at the same time, and now I push the slide gate in, and you will see that at this time I take the vacuum level away here, and here it's increased, because here is a resistance, or in this case a blockage in the duct system. If I really block it, here I have no more vacuum, and here I have all the possible vacuum I can get. That means, if we know this, with a simple gauge taking static pressure measurements across the system, we can say here, right here, is a jump in the static pressure, and that means here is a resistance or blockage or partial blockage. In a total blockage, this goes down to 0, and in a partial blockage, it will create a certain delta P, which is very high now, and if I take the resistance away, I will say, oh, now these two static pressures are basically the same. I do it one more time. You watch these instruments at the same time. I push the slide gate in, and you will see these instruments will show this one a lot of vacuum, and here the vacuum will decrease. You can see it. So with a simply static pressure gauge, I can detect a blockage. Now, what's very important, at the same time we do this, so I go back to base condition, and now I watch what the fan is doing. The fan is right now, this is the airspeed in the duct, and that's the differential pressure created by the fan. You remember well, when we're speeding up the fan, both of this goes up. Let me do it one more time. When I speed up the fan, the airflow goes up and the static pressure goes up. So I go back to base condition, but this time I do another experiment. I go back to the slide gate, and I will create resistance, and I want you to watch these two instruments. So now I create the resistance, the airspeed goes down, and the differential pressure created by the fan goes up. I go back to the base condition, which was roughly here. I do it one more time. I slowly create back pressure and resistance, and I will see that the airspeed through the duct system will go down, and the differential pressure by the fan will go up. Now, I will now do that on the pressure side of the duct system, and it's the same thing. On the pressure side of the duct system, if I push in this slide gate, the airspeed will drop down and the delta P will increase. Look at this. And this time I want you to see these these ones. These ones are showing the static pressure here and there. And at the moment I push this one in, this one should go up and this one should go down. Let's do it. Yeah. And again here, there's a big pressure drop from here to there, and you can measure it and say, this is where the pressure drop is. Now, I hope, let me shut this down. In summary, what I want to say, and that's the true power. If I have a pitot tube which will tell me the airspeed in a duct system, and if I have some gauges which are telling me the static pressure inside a duct system, I will be able to identify any kind of back pressure, resistance and blockages in a duct system. Once I understand that, that's very powerful. That then I have a very simple instrumentation that I can use for troubleshooting to see if the air balance is stable. Am I operating at my target condition in terms of vacuum and airflow? Is it stable, or is there maybe the transportation speed and there can be all kind of problems. I give you some example. Maybe the duct sizing is too big, resulting in a very low transportation speed, which I can identify with the pitot tube, and the low transportation speed will result into accumulation of material inside this duct system and eventually in a blockage. I can also identify if I go with my static pressure measurement tool, I go along the duct system. If I have an abnormal jump in the static pressure, that means I should dig deeper, and I will then find any kind of leakages or blockages in the system. And when you start doing these things, it is a little bit like you would use a voltmeter and an ampere meter to troubleshoot an electrical system, a circuit. You can do magic things with these simple tools. You can troubleshoot any kind of system. Yeah, this one, that would be your ampere meter because it measures flow. And these ones, which are measuring the static pressure, they would be the equivalent of a voltmeter to measure potential or static pressure, voltage. I hope that this demonstration will help you to understand your air systems on a bigger level. What I can recommend to you is the following. If you have a plant where you have some fans working, 5, 10, 100, 500 fans, it is worth for you and your team to know more about this technology, to deeply understand the interaction of the fans and your system and your process and the energy consumption. It is really well invested time if you train your process engineers and also down to the operator levels about this physics behind the airstreams. It is value for you. So I recommend you to go out and take some old fan which is just sitting around on the shelf in your factory, take some old ductwork. This is a simple Testand. I know it's not so beautiful, but it reflects all you need. Build a simple system, change the diameters, do some slide gates in it, put a frequency inverter, and then let your operating personnel play with this. And by playing with this, doing this and that, they will understand deep down, they will understand how this system works. They can verify how easy it is to use a pitot tube and static pressure measurement gauges.